So today we're going to talk about solve equations involving absolute values. Okay, so that's what we're going to be talking about. How to solve equations that involves absolute values. So before we talk about equations, I want to talk about then some expressions that involves absolute value. Let me give you a very simple one. And I think everyone would get this pretty understands. Okay, I think a lot of you know what the simplified answer for this is. How do you simplify absolute value of -3? What does it become? Everybody? 3. It becomes 3. You guys remember? And of course, what's absolute value of just 3? Still 3. They're both 3. Isn't that right? Because what does absolute value really tell you? What is it that we're looking at here? Do you remember? Yes.
How far away is it from 0?
How far away is this number from 0? That's exactly right. So, of course, from 0, right, that's the key, right? From 0, if to go to -3, how many units do you have to go? 3 units. That's what it's telling you. And of course, from going from 0 to 3, of course, it takes the same amount of units, right? 3 units. And of course, distance is always positive, so that's they're both positive, right? Absolute value of either positive or negative number is positive, right? Okay, so that's the idea. But we're not going to just talk about expressions. We're going to talk about equations, okay? Absolute value equations. So let's look at some equations that involves absolute value and how to solve these, okay? All right, here we go. So here's our first example. Example 1. We have an equation now. Absolute value of x equals to 3, right? Now, this is a very simple equation, as you can see. And what are we trying to figure out here? We're trying to figure out the value of x so that what? Yeah. So that it equals 3. So you can plug in anything for x, right? And once you take the absolute value of that number, we want to make sure it comes out to 3. Turns out there are more than one ways for this to be true. What's the most obvious one? When x equals, of course, 3. But there's another way for this to be true. Angel? How many people agree with Angel? Yes, it could be negative. It could be -3. Would you not agree? Yep. So we're looking for the value of x that makes this left side equal to the right side. And because left side has an absolute value there, right, there are 2 ways for this to be true. So first way, of course, you could think of it this way. You say, of course, x could equal to 3, right? We're just looking at what's inside of the absolute value, right? If x comes out with 3, of course it's 3. You could also have negative x, right? Or -1 times x is equal to 3 also, right? Because if you were to take absolute value of this negative x, right, wouldn't that come out to be 3? Well, how do you solve for x in this case? Divide both sides by -1. So what's the other answer? X could equal to also -3. So there are 2 ways to, so you could write it as a set notation like this, right? Does that make sense? Because negative x also could equal to 3. That means, of course, x could equal to 3. Does that make sense? Right? Does that? Okay. By the way, why do you think I used the word "or" in between these 2? So x could equal to 3 or x could equal to -3. Is it possible? Is it okay for me to use "and" in the middle? No. No, that would not make any sense. Why not? Why can I not say x equals 3 and x equals to -3? Yes? Exactly. You're saying x is 2 different numbers at the same time, right? If you say and x equals 3 and -3, that's not possible, right? You can't have one number representing, right, both positive and negative, except for 0, I guess. I mean, but you guys understand? So that's why we need to use the word "or." That's important. Okay? All right. So let's look at something a little bit more interesting than this very simple example. Okay. So let's move on. All right, so take a look at example 2. We have absolute value of 2x plus 1 equals to 5. Again, even though it's not as simple as before, the idea is the same. What can that expression inside the absolute value equal to? First of all, Jason, 2x plus 1 could equal to what? Well, okay, so yeah, don't look at the x. I'm just talking about this whole expression. What can this expression 2x plus 1 be equal to so that it equals to 5 when you take the absolute value of it? 2x plus 1 could equal to? Any idea? Okay, discuss with your team. Go ahead, everybody think about it. What do you guys think? So, Jason, what did you guys come up with? What'd your team say? 2x plus 1 could equal to?
5.
5 or?
2x plus 1 equals -5.
Yeah, it could equal to 5 or -5, right? There are 2 possible ways for this to be true, correct? Would you not agree? How? Because if 2x plus 1, first of all, let me write that possibility here. If that expression inside the absolute value comes out to be 5, What is the absolute value of 5, class? 5.
Or negative 5.
So we just have to figure out which x makes this expression equal to 5. Easy enough? Well, that's not the only way for this to equal to 5, right? Yeah, the 2x plus 1 could also equal to negative 5, right? Or I could just, so yeah, that's the shortcut. The reason why negative 5, because negative of this could equal to 5, right? So that's the same thing as 2x plus 1 equals to negative 5. Does that make sense? You divide both sides by negative 1, same way. Normally, you would just go to this, straight, you would just go straight to 2x plus 1 equals negative 5. Does that make sense?
Oh, I solved for that.
Yeah, so we're solving for x. And do we know how to solve for x for these simple equations now?
Yes.
Yes?
Wait.
Can you figure out which x makes it equal to 5, and can you figure out which x makes it equal to negative 5? Can you do that? Go ahead, everybody try. I'll wait. That's pretty simple, right? So, here we go. Who can tell me what I get on the left side when I solve for x? How about Aaron? What'd you get?
Left side.
Huh? The equation on the left side you get?
2x equals 4.
That's what I got. 2x equals to 4, right? Well, is that what you leave it as, or don't you? Then divide both sides by?
2.
So you get?
2.
You got it. What about the one on the right side? By the way, you normally just write 2x plus 1 equals negative 5. I'm just showing you why it equals negative 5, right? It's because negative of this should, right? Should still come out to be 5, right? Does that make sense when you take the absolute value? So I'm just kind of showing the work here. But you would just write 2x plus 1 equals 5, or 2x plus 1 equals negative 5, right? That's kind of a shortcut. But this is kind of interesting to see. You know why in a minute, why I wrote that down. Okay, next, of course, here we subtract 1 from both sides and divide both sides by 2. Did you all get x equals negative 3? Okay, so there are two possible ways for this to be true. If you don't believe me, plug it in. Look, what do you get when you plug in x equals 2? You get 2 times 2 plus 1, which is 5. What do you get when you take the absolute value of 5, guys? 5. What do you get when you plug in negative 3? Here, the negative 3. 2 times negative 3, which is? Negative 6 plus 1, which is? Negative 5. What's the absolute value of negative 5? 5. So see, there are two possible ways. So whenever you have absolute value problems, okay, please, you got to think about both of the case, right? There are two cases for the true. So for your answer, you just write this. X could be 2 or x could be negative 2. Is this easy? Do you guys get that? Okay. Let's look at something more interesting than this then. Here we go. Okay, take a look at example 3. Now this time we have some fractions, but it shouldn't really scare you or anything, right? Christina, there are two ways for this to be true, correct? You got this whole absolute value of this expression, x over 5 minus 2 equals to 4. There are two ways for this to be true. What are those two ways? This is true if what?
Oh, if 6 minus 2 equals 4. Oh, no, but it has to equal 4 negative 4.
Yeah, so what has to equal to 4 or negative 4?
Does it, if it's in there, it doesn't have to be 6?
Yeah, don't think too hard there. Just look at what's inside the absolute value. We got x over 5 minus 2, right? We want to make sure x over minus 5 minus 2, x over 5 minus 2 should equal to what? Either 4 or negative 4. That's it. Don't think too hard. There are two ways for this to be true, right? Right? The expression inside, this is only true if, right? The expression inside of the absolute value comes out to 4 or negative 4. Do you all know how to solve these equations? Go ahead, everybody try. I'll wait. Okay. I'm going to include in there, just like you know how we did this before. This is true if, right? Isn't this only true if x over 5 minus 2 equals 4 or x over 5 minus 2 equals negative 4? Right? There are two cases. Okay, go ahead, everybody solve. Okay, so who could tell me what we get for the equation on the left? X over 5 minus 2 equals 4, of course. What do we get here? Samara, what did you get? X equals 2?
She said 30.
Oh, I didn't hear you. What did you say? 30. How many people agree with Samara? Very good. It is. I believe it's 30. There you go. It's 30, right? What about the equation on the right? How about, who haven't I called? Claire, what did you get for the one on the right?
Negative 10.
How many people agree with Claire? Very good. You guys are all correct. So, did you guys include that word or in the middle? That's important, okay? Can I just leave it out? No, you shouldn't, okay? So, you got to be careful. You got to be careful to write that as, you have to say x equals 30 or x equals negative 10, okay? You need to write that word or, okay? So, any question? Because x could be 30 or negative 10, okay? All right, let's move on to a little bit more interesting ones now. Is that okay? You guys get the idea? Here we go. All right, so let's take a look at example 4. They got a little bit more creative, and I put a star on this because, this should be equal to, we're not there yet. So equal to 21, okay. So if you have an equation like this, There's a reason why I put a star on this. What would you do, first of all? First of all, whenever you have equation with the absolute value, you got to have the absolute value by itself, right? We got all these other numbers around, so is there a way to get rid of them? Because we don't know how to deal with it when it's like this. You have to have the absolute value by itself. Eric, what would you do?
You would subtract 4 and add 4. I mean, subtract 5 and add 4.
5 and 4. Okay, how many people would do that first?
That's wrong.
Okay, good, thank you. Because that's what I would have done too, Eric. I'm glad you said that because that's the part where people make that silly mistake and get the whole thing wrong. Eric, why can we not do that? Because it's so inviting, right? 5 minus 4 is 1. We know how to do that. But why can't we just subtract 5 minus 1? It just makes it so much easier. Why is it that we can't do this, Eric? Okay, I want you to discuss with your group because that's the part where people always mess up. Think about it. Why not? Ask your team. Go ahead. Discuss with your team, guys. So, Eric, what did your team come up with? Why is it that we can do 5 minus 4? It just becomes 1. It makes it so much easier, right? But why would that be wrong? Good. 4 with the absolute value. What operation is right between 4 and the absolute value, guys? Multiplication. You have to follow the order of operation every time. Just because you get a nice number like this, you can't just, do that step first, right? Because then if you don't follow the order of operation, of course, you're not going to get the right answer, right? So what should we do then? So what are we going to do for this? Well, we have to get rid of these. Is there a way to get rid of these things? Bella, thank you for...
Couldn't you multiply negative 4 to the 2 minus 3x?
Oh, why don't we distribute this, right? But the absolute value doesn't work like a parentheses. So we don't normally do that, okay? So we don't want to do it that way. We just want to get rid of all these numbers around it so that we have the absolute value by itself equal to some number and use the same method that we just did. Does that make sense? Good. So a lot of you are thinking, okay, why don't we distribute? Not quite, because absolute value isn't the same as the parentheses. So Bella, what can we do?
You divide it.
You want to divide both sides by what?
By the negative.
Divide both sides by -4 first, you sure?
Or 1.
What about this 5 then? You're going to have some fractions. So could we get rid of that 5 first? Yeah, what should you do? Subtract both sides by? Yeah, that's what you want to do first. Right? As if you have, like, you know how you solve for x or something like that? Treat the absolute value, the whole thing, as like x. If you had like 5 minus 4x, wouldn't you subtract both sides by 5, then divide? So you don't get any fractions and things like that. So this is what you would do first. And you get -4 absolute value of 2 minus 3x equals to 21. What's 21 minus 5? It is 16. Then what are you going to do? Then divide both sides by -4. Very good. You see? So then you get absolute value of 2 minus 3x equals to, what is this? -4. You see, now we know how to do this. Here, then we say, okay, we know what to do now. Whatever that's inside the absolute value could equal to? 4. -4 or 4, right? But, think about this. Is this even possible? Why not? You're right. So the answer, okay, so think about it. Everybody think about it. What does this mean? Go ahead, everybody think about this. So many of you, okay, at this point, you don't need to even write those two possible ways because what is your solution for this? Okay, why is this? Okay, why is this? How come I didn't do the way that we did before? Why do I say no solution? 3 people see it? 4? Patty, why not?
Because it's -4 in that.
Yeah, if you take absolute value of any number, can you take absolute value of any number and make it equal to negative? Is this even possible? So at this point, when you have absolute value equals to some negative number, you know that there's no number on a number line that you could plug in, right? To make it negative. It's impossible. Does that make sense? Of course, if it equal to 4, then yeah, you get 2 cases,
Or
right?
if there was a negative on the outside.
Yeah, if there's a negative on the outside, of course, you would divide both sides by negative and so on. Does that make sense? So whenever you have the absolute value by itself, that's the key. Whenever you solve absolute value problems, you want to get the absolute value by itself. And like in this case, there's no solution because it's impossible. Again, if it was equal to +4, then we do the same way. Now, some of you are saying, could I just change what's inside here to 2 plus 3x or something like that? Can I do that? Because there's an absolute value. Does that make everything inside as a positive number? No. Please be careful. For example, right, if I have absolute value of 2 minus 3, is that equal to absolute value of 2 plus 3? Of course not. Yeah, this is absolute value of -1, which is what?
1.
Does that make sense? Just because you have absolute value doesn't make everything inside positive. Okay, please be careful with that. Right? Does that make sense, guys? After you simplify everything, right? If it's just numbers, then of course it becomes positive. Here, you got some variables in it, then so you can't even do that, right? This is simplest right? This is a simplified way to write. So you can change that to like 2 plus 3x. That'll be wrong. Does that make sense, guys? Okay, so please keep that in mind. Anyway, okay, so let's do some other examples now. So please, again, when you look at the very beginning, a lot of you will see the 5 minus 4, you would put 1 or something. That'd be wrong. Please don't do that, right? This is 4 times this. You must follow the order of operation. Does that make sense? All right, let's go on to the next example. Now, this time, it's kind of interesting. Instead of equal sign, we have an inequality. Right? We talked about inequalities yesterday. This time, it only has one variable. So we're going to just talk about them in terms of one variable. Absolute value of 3k minus 2 less than or equal to 7. So, in this case, whenever we have an absolute value of an inequality, let me show you how to do this. We haven't seen this before. There are two, you know how we have absolute value with the equation, you get 2 equations? For inequalities, guess how many inequalities you get? You get 2 also. Just like when you have absolute value of an equation, you get 2 equations. With inequalities, you get 2 inequalities again. So let me show you. The first one is really easy, just like the absolute value of equation. What do you think the first inequality we get? It's the same exact one without the absolute value. So yeah, you're right. So the first equation, this is only true if this is true. That's the first one. 3k minus 2 less than or equal to 7. Now the second one is where it kind of gets interesting. Second one inequality you get, it's the same one. So the one inside the absolute value is the same, 3k minus 2. Guess what we do with the absolute value? We reverse, and guess what happens to 7? It becomes negative 7. And let me show you why. It's because you can think of this as, right, look at what's inside of the absolute value. 3k minus 2, right? That whole thing could be negative, isn't that right? So remember when you divide both sides by negative, what do you get? You have to reverse the inequality symbol and that number becomes its opposite, right? Does that make sense? So that's the reason, but this is a shortcut. So there are 4 things you got to do. First, you have to write the whole thing without the absolute value, right? That's the first inequality you get. Second one, you write the same one, but you reverse the inequality symbol and write the opposite of it. And here, how come I got and in the middle? It's because, look at the symbol. It's less than, right? So I don't know if you remember from last year, this is conjunction. Okay, if you don't remember, don't worry about it. So when you get an absolute value, okay, you got a conjunction and disjunction. Anyway, if you don't remember, don't worry about that. But hear me out here. Whenever you have the absolute value, less than symbol, okay, remember less than, see, then ends with an, right? So remember it's going to be and. Okay, so that's how you remember that this is and in the middle. Okay, so how do you remember it? It's less than, so it's and. Okay, but some of you say, wait a minute, greater than, that's still, there's than in there, right? But for greater, we'll talk about that in a minute. But for less than, so when it, just remember less than goes with and, okay? So for now, I just want you to understand it this way, okay? So we'll explain this a little later, why this is and in the middle. Again, it has to do with conjunction and so forth, but we're not there yet. So whenever you have less than, please use the word and, not or. Is that okay? So go ahead and solve these inequalities and tell me what you get. I'll wait for you. Go ahead, everybody try. So the first inequality, like I said, that's the easy one. It's the same exact one without the absolute value, right? It's one on the left. So what are we going to do to solve for k? Matthew? You add 2 and divide by 3. Isn't that right? So when we do, we add 2 to both sides, divide both sides by 3. Do we reverse the inequality when you divide by 3? No. Okay, when do we reverse the inequality? Only when you, when you divide or multiply by negative number. So there you go. You get k, how many people got k less than or equal to 3? Okay, very good. Right, what about the second one here? What do? We do the same thing now. We add both sides by 2, and don't we get 3k is greater than or equal to negative 5? Then what do? Divide both sides by 3. So you get the 2 inequalities. And some of your and that and, because we had less than, just remember it like that, okay? So if you ever forget, less than, right? It ends with a n, right? So less than n. So that's what we get. So that's the solution. K is less than 3 and k is greater than or equal to negative 5/3. Now, we're not quite done, because whenever you have systems of these inequalities, okay, you have to graph it. And now we only have one variable, so we're going to graph it on where? On a number line. Does that make sense? It's not going to be on a x and y axis, because that's for 2 variable inequalities, right? Do you guys remember this from last time? This time we only have 1 variable, so you could graph it on a number line. So how do we graph How do we graph k less than 3? Well, let's look at this number line now. Here we go. So here's what we do. We got number line. I got 2 numbers on this number line. You don't have to fill in the rest of them. You just, I'm going to plug in 3 and negative 5/3. Okay? By the way, how come the 3 is on the right side of negative 5/3? I got 3 first. So shouldn't I put 3 on the left and then negative 5/3 on the right?
Oh, negative 5.
Yeah, why not? Clear? How come so I got 3 first, right? So shouldn't I write 3 first and then negative 5 over 3 on the right side?
No.
Why not? Yeah, which one is smaller? Negative 5/3. Okay, so please don't make that silly mistake, okay? Just because you get the number first doesn't necessarily mean you're going to put that there first, okay? So then how would you graph this, okay? Here we go. So, how do we graph k is less than or equal to 3? By the way, do we include 3? For this, do we include 3? If it says k is less than 3, is 3 included in this? Yes. So that's why I put a solid dot here. Does that make sense? Is that all? How do we graph this on a number line? K less than or equal to 3.
Oh, I remember this.
Do you guys remember from last year? How do we graph this? Where are all the values of k that is less than 3? On the left side of it or the right side of it?
Right, left.
Left side. So everything to the left of this, right? What about k that is greater than or equal to, thank you, greater than or equal to negative 5/3? Do we include negative 5/3?
Yes.
Yeah, that's why I have a, let me do this in red. That's why I put a solid dot there, right? Because it includes that negative 5/3. Where are all the values, the k, that are greater than or equal to negative 5/3? Is it on the right side of negative 5/3 or the left side? Right side. Do you see that? Now, some of you say, why do we need that word and? Do you see why we need that word and? Because,
Both.
yeah, it has to be true for both. And means it's got to be true for both. So guess what? Is this whole graph our solution or just the overlap? Just the overlap. So this is why we need that word and in the middle. Does that answer your question? So the solution then, the solution to this inequality, when you graph it, you can see it a lot better. So whenever you have these, you must graph, okay? So when you graph this, you get this graph. As you can see, you get all the numbers between negative 5/3 and 3, including the endpoints. Does that make sense? Okay. So, and another way of writing that is this. Have you ever seen this before? Where this inequality means the same as k in the middle, and then you got k's between negative 5/3 and 3, and you include the endpoints. So they all mean the same thing. Some of you, sometimes they represent these inequalities, they kind of put them together. Do you see how they did that? It says k is between, you see, look at the graph. Isn't all the numbers of k must be between negative 5/3 and 3? So there's another way of writing this inequality. This actually puts 2 inequalities into one place, right? With one statement, kind of. So this really represents 2 inequalities. K that is greater than negative 5/3 and k that is less than 3. Does that make sense, guys? Look, k, and it's kind of nice, right? You can see that k is between negative 5/3 and 3. Okay? All right. So if we just had k less than 3 and k greater than negative 5/3, what would the endpoints look like? Would it be a solid dot or something else? It would be something else. It would be just an open circle, which indicates that we don't include the endpoints. So we're going to do something like that in a minute. Very good question. So there's a solid dot is because it says k is less than or equal to 3 and then k is greater than or equal to negative 5/3. Okay, if it didn't, then it would be open circle at the either end. It's kind of like the dotted lines. Remember we had dotted lines for those boundary lines? That's the idea, right? Okay, so that's a good question. Let's do one where we don't have that. We'll do that in a minute. Okay. So take a look at example 6. 4 plus absolute value of 3. 4 plus 3 times absolute value of 5x plus 1 is greater than 18. Now, Jason, can I add 4 and 3 right now? No. Why not?
Because it's in the order of.
You got to follow the order of operation. You got to multiply first. But we don't know how to multiply absolute value with a number, so we're going to get rid of all the numbers from left side. Right? Isn't that nice? It's kind of nice when you have an equation like this. An inequality. So what should we do? How do we get rid of that 4 and 3 here? Camilla? Subtract 4, of course. Then what do we do? Divide both sides by 3. So look what I wrote here. This is important. You must have absolute value by itself before doing anything. Okay, whenever we have 2 inequalities, right? You gotta have the absolute value by itself. Are you okay? So look at this symbol. It's great tall, right? So guess what number Remember we had less than, so we wrote and before. Now greater, how are we gonna? What do you think? I misspelled this on purpose. Which word do you think we're going to put in between the two inequalities, Chuck? Or. Does that make sense? Greater. So that's how you remember. If you have the absolute value greater than some number, you're gonna have or. If it was less than, what are you gonna put? And. Okay. So now go ahead, everybody. Then write the two inequalities that we get. I'll wait for you. Go ahead, everybody try. What are the two inequalities we get here? So the first one is always easy, right? The first one is, it looks exactly same as what we had without the absolute value, right? So 5x plus 1 greater than 14 over 3. The other one, you got to do two things, correct? What word goes in the middle, by the way?
Greater than.
Greater, or, okay, or, so, or, and then you got to do two things. The expression in the absolute value stays the same, so 5x plus 1, that's the same. But what do we do with the greater than sign? Now it becomes, it becomes less than, you got to reverse. And then what about 14 over 3? It becomes negative. Does that make sense? Okay.
Yes.
Okay, so did you all get this?
Yes.
Go ahead and now solve both of these inequalities. Tell me what you get. So on the left side, did you all subtract both sides by 1? Okay. How come I wrote negative 3 over 3, by the way? How come I didn't write 1? Yes.
Because
You need a common?
denominator.
Yeah. So when you do, did you get? I got this. X greater than 11 over 15. Yes? Right? Because 14 over 3, if you subtract 3 over 3, don't you get 11 over 3? And then divide both sides by 5 or multiply by 1/5. Same thing. Correct? What about the other one? Did you get? I got x is less than 17 over 15. I'm sorry, negative 17 over 15. Is that okay? Okay. All right, here we go. So, how do we, okay, that's the answer. Okay, now how do we graph this? Well, look at the first one, x greater than 11 over 15. Do I put an open circle or a closed circle? Open. To the right of it or left? It says x is what? Greater, so it's going to be? Right. By the way, you always want to read with x first, okay? Don't write the number first, because if you say 11 over 5 is less than x, it's kind of confusing. Always read it with the variable, okay? And the other one, x is less than, open or closed? Open. To the left or right? To the left. Because it's less than, right? Always read with x first. Now, it says or, so do we look for the, where they overlap, or do we include all of them? Just we include all of them, so this is your graph. Does this make sense? Yes. Can you do something like this for your homework? Yes. Okay, very good.